Let's continue on with 6C. We've done all of the instructional part of it, so this is just additional practice for us. So let's see what we got going here. All right. Suppose that the heights of all men are normally distributed with a mean of 70 and a standard deviation of 4. So we have a normal distribution, a mean of 70, and a standard deviation of 4. Okay. So the first thing we need to do is to be able to label these. So the mean of 70 means that right here, smack dab in the middle, is our 70. We have 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left. For each one on the right, I'm going to add 4. So this becomes 74, 78, 82. For each one on the left, I subtract 4. 70 minus 4 is 66, minus 4 is 62, and minus 4 more is 58. Okay, so 1 standard deviation, 2, 3. Now, the thing that I want us to remember on here is that between 1 standard deviation, this is 68% of the data. For 2 standard deviations, I'm going to draw it above here. This is 95% of the data. And then finally for the last one, for 3 standard deviations, this is 99.7% of the data is in between those values. Okay, so if we remember that, then we're pretty good that this is the mean 1, 2, 3, negative 1, negative 2, negative 3, and these values. Okay, so what percent of men have heights between 62 and 78 inches? So 62 and 78, so here is 62, here is 78, here is our mean. This is 2 standard deviations. So that gives us 95% of the value. What percent have heights outside these areas? Well, we're going to look at our 62 and 78 again. If 95% is in here, then outside is going to be 100% minus 95%, which is 5%. Okay. All right, what percent of men are shorter than 74 inches? Okay, well, we see 74 here as 1 standard deviation. So what we're looking for is everything. Okay. Now, what we know about 74 inches is that it's 1 standard deviation, so in between here is 68%. But I need to know this other half. So if all of this is 68, then that tells me in here, if I look at just this portion here, this is 34%, half of 68. Well, I know the mean means that this is the center of the data, so it's cut in half. So everything to the left of the mean is 50% of the data. So I have 50% plus 34%, which is 84%. Now you can do it a different way as well. You know all of the data is 100%. And you know if this is 34%, then this here is 16%. Because this is half of it, 34 plus 16 is 50. So you could do 100% minus 16%, which is also going to give you 84%. Okay. Well, and so doing it this way, I've actually answered the next question. What percent of men are taller than 74? Well, we know this is 1 standard deviation. So we know that from here to the center, this is 34. And we actually just did that. All of this from here to the end is 50%. So 50% minus 34% gives us 16%. We could also have done it using this. We found that from everything from here to the left is 84%. So 100 minus 84 is 16. Okay, what percent of men have heights between 58 and 74? Okay, 58 and 74 are on here. They are not the same number of standard deviations. So let's see what we've got here. Well, here is 74 at 1 standard deviation. And down here is 58, which is 3 standard deviations. And we want to know everything in between. There are several ways that you can approach this. Okay. Now here's how I did it. And this makes sense to me, but it may not necessarily make sense to you. Okay. I went back to those figures that we had on the front. And knowing those 3 things, I know that from here to here is 68. Half of that makes this 34% of the data. I look at my 3 standard deviations, and I know from here to here is 99.7. Half of that is 49.85. Whoops, I'm sorry, you can't see that. So this gives me a total of 49.85% plus 34% gives me 83.85%. That is in that category. Now, there's another way to do this. We could use the information from up here. We know that from here all the way to the end is 84%. We already found that. Okay. And I also know that since this ends here, that this little tail over here, from here over, is 0.15%. So I could do it as 84% minus 0.15%, which is 83.85. Again, there's no right or wrong way. You just have to do it however you see it. Okay. Alright, now I'm going to change this because cut and paste is your friend if you actually remember to adjust it after you cut it and paste it. Alright, in a group of 600 men, how many would you expect to have heights between 58 and 74 inches? So we're looking at the same thing here. We're looking at this here. And we know from here that this is 83.85% of the data. Okay. So we are looking for 83.85% of the 600 men, which is 0.8385 times 600, which turns out to be 503.1, and I'm going to round that to 503 men. Okay. All right, let's look at some information about rent in Austin. Okay. I looked this up, was a little bit surprised. According to one publication, the average monthly cost of renting an apartment is about $1,400. It's actually $1,398 with a standard deviation of 300. Okay, label the graph. All right, so once again, we've got those magic words. $1,400. The average, which is the same thing as mean, is 1,400 and a standard deviation of 300. I did not put in the problem that it was normally distributed, but that's what this whole section is about. Okay, so this is 1,400. To fill out my chart, one standard deviation to the right, add 300, add another 300, add another 300. Start subtracting 300, subtract 300, subtract 300. Okay, so the first one wants us to find what percent of apartments rent for more than $1,700. So that's everything from here to the end. We know, of course, this is one standard deviation. We know that from 1,400 to forever is 50%. So we have 50% minus 34%, which gives us 16%. What rents for less than 1,100? Well, this is one standard deviation to the left. Notice the size and shape of this is exactly the same as over here. It's just on the other side. From here to the left is 50%. We're going to subtract out the 34%. That is one standard deviation to the left. And again, we get 16%. Now again, I'm going to change this. What percent of apartments have a rent between, let's make that $800 and $1,100 to fit the graph better. All right, so what I'm looking for is all of this here. From between 800 and 1,100. Okay. And again, there are a couple of ways to look at this. I know from two standard deviations that this is 47.5%. One standard deviation is 34%. So I can do it that way. I can say Well, it's 47.5%, the 2 standard deviations minus the 34%, which is 1 standard deviation, which gives us 13.5%. The other thing I can do is that I know that from here to the end is 16%, and I know that this is 2.5%. So I can do 16% minus 2.5%, which still gives me, whoops, 16% minus 2.5%, and that still gives me 13.5%. Okay, the next one asks us about z-scores. If the z-score is negative 1.2, what is the rent? Okay, well, if I have a z-score, I can find the data value. So we know that the data value is equal to the z-score times the standard deviation plus the mean. So in this situation, it's negative 1.2 times the standard deviation, which is 300, plus 1400. So negative 1.2 times 300 plus 1400. And that gives me the rent of 1,040. Okay. An advertisement for an apartment states that its rent is in the 70th percentile of all apartments in Austin. What is the rent for the apartment advertised? Okay, so we have to go to our z-score table, and we're going to look for 70%. Okay, so there is no exact 70%, and these are really close. So actually, I would go with this one right here. I would go with 69.15 is closer to 70 than 70.88. So the percentile leads us to a z-score of 0.50, and then to find the rent, we just use the same thing from up here. So it's going to be 0.5 times 300 plus 1400, which gives us 1550. Okay, if the rent of an apartment is 1950, what is the number of standard deviations? So I'm just looking for a z-score. So we know that the z-score is equal to the data value minus the mean divided by the standard deviation. So that gives us 1950 minus 1400 divided by 300. So 1950 minus 1400 divided by 300, and that's 1.8. Now that kind of makes sense, because 1950 is between 1700 and 2000, probably somewhere right in here. So this would be 1950. So this is 1 standard deviation, this is 2, so it would go right in between there. If the rent is 680, what is the z-score? I'm going to use this exact same formula. Z is equal to, now let's look at the table. If this is -1, -2, and -3, I would expect, and our data value here, -650, I would expect it to be around 2.5, -2.5. Okay. All right, so this is going to be our data value minus our mean divided by 300, which in fact does give us -2.4. Okay, that's it.